Hi everybody, welcome back. So today's syllabus is Broadband Isdn, IP Networking Protocol Architecture, OSI Reference Model. So starting with the Broadband Access System, BISDN, Broadband ISDN. So basically BISDN specifically provide delivery of multimedia services such as constant bitrate voice, hi-fi audio, high-speed data, internet access, video conferencing, high density TV, HDTV services, etc. up to 150 Mbps level. Second one is fast packet switching by asynchronous transfer mode ATM that enables delivery of BISDN services. The services which are responsible behind this BISDN is ATM, and it is defined in application layer. Then we have SONET SDS frame on optical fiber as physical layer that carry ATM wideband services. So now let's study IP networking protocol architecture, which is very important for telecom aspect. So we all know OSI model. We have application, presentation, session, transport, and network and data and physical layer. We will study in detail depth of each and every layer. Proportionally, we have TCP IP architecture, where application presentation session layer is clubbed in application layer, transport is TCP, and network layer in OSI becomes IP networks in TCP IP, and data and physical layer is combined into network access. So basically TCP IP architecture, we have four layers. In hybrid model, we have application, TCP IP, data link, and physical layer, which is nothing but a 5-layer combination. So this is the basic model in which every telecom IT equipment works, and we will understand what is the functionality of each and every layer in the next slide. Let's work on OSI reference model, Open System Interconnect. It's a ISO standard model, and it some have key characteristics such as layered architecture. Each layer perform a distinct function as defined by a set of rules protocols. Then we have N provide service to layers, that is N plus 1, and uses services of layer N minus 1. Interfaces are defined for the layer boundaries. Different nodes have peer protocols. The different functions performed in OSI are application services, control, addressing, routing, and physical transmission of data. Now, layer functionality. Application layer provide services such as web services, email services, remote login, client server, database, games, network, and management. The application we see in general in our system, these are the working on application layers. Then we have presentation layer, which deals with syntax, data representation, compression, encryption, and file translation. Then we have session layer that manages start and closing of a session or transaction or TX and RX coordination, login procedures. Transport layer performs reliable and efficient delivery of data from end to end. Application data is fragmented into smaller protocols unit, that is called protocol data units called segments, encapsulate them and send from source host to destination host. So this transportation is responsible by the transport layer. Then we have network layer, which fragments and encapsulates the segment into smaller data units called packets that the network can handle. Add source and destination host address. It is connectionless and enable best effort delivery of packets. Routes packets to the destination using routing algorithm. Then we have data link layer, responsible for framing, media access, error detection and correction at bit level. It's very important for correction and error detection in data link layer. Then we have physical layer, which deals with the transmission of bit and provides hardware interface to the network. It defines the basic frequency, voltage, levels, cabling, terminal topology, etc. So this is important for the physical connection of the data transmission. So we have discussed all the 7 layers. I hope this video is quite clear to all of you. If you do have any queries, please put it down in comments, and let's move to the next video.